Hi, welcome to this lesson on trigonometry compound angles. Let's have a look at question 4. Again, we're given an equation where a restricted domain from 0 to 360 degrees wants to be solved. So let's go ahead and figure out how we can do this. So again, we have cos and sines in here. And the goal is to try and see if we can use compound angles to help simplify that expression on the left. Well, I have the numbers a half and √3/2 in front of the cos and sine respectively. That instantly triggers an alert in my brain saying, where have I seen the numbers a half and √3/2 before in trigonometry? Well, those are special angles, all right? So I could see a half, right? A half could either be sine of 30 degrees or it could be cos of 60 degrees. And then √3/2, that's either sine of 60 degrees or cos of 30 degrees. So we could use either one. So let's see what happens if we use 30 degrees, for example. So instead of saying a half, I'm going to say sine of 30 degrees times cos of x minus, instead of √3/2, I'm going to write cos of 30 degrees times sine of x equals a half. So I have sine, cos, sine, and the angles are in the proper order. So this is the sine compound angle formula of A, which is 30 degrees, and because it's minus, you keep it as minus, x, which is your B, equals a half. Alternatively, we could have done it this way. We could have said, well, instead of a half, I could have put it as cos of 60 degrees times cos x, and then √3/2, that was sine of 60 degrees times sine x equals a half. So where have you seen cos, sine before? Well, that's the cos compound angle. There's your A and there's your B. So it's going to be 60 degrees and x. And because the negative sign is there, it becomes positive in the middle, equals a half. So look at the two equations you have. They look different, but they're actually exactly the same, right? Because of co-ratios. So we'll solve both of these equations and see that we get the exact same solutions. Okay, so let's do the right-hand side first. Well, on your cos diagram, where is cos positive? That's in the first and fourth quadrants. Okay, so your x plus 60 degrees is going to equal, so for the first quadrant, you need the reference. Cos inverse of a half is 60 degrees. That's your reference angle, plus k times 360 degrees. So here you're going to get x equals, if I subtract 60 on both sides, I just get k times 360, where k is an integer. And then in the fourth quadrant solution, you're going to have x plus 60 degrees equals 360 minus your reference, which is 60. That's going to be 300 degrees plus k times 360. And then if I subtract 60 degrees on both sides, I get x equals 240 degrees plus k times 360, where k is an integer. Okay, so if I put in k equals 0 for the first quadrant, I get 0 degrees. Okay, because here's the general solution for both. Okay, so 0 degrees for the first quadrant. If I put k greater than or equals to 1, the only applicable solution is going to be x equals 360 degrees. And then k less than or equals to -1, there's going to be no applicable solutions because of this domain. And then if I put for the fourth quadrant, k equals 0, it's going to be x equals 240 degrees, which is applicable. K greater than or equals to 1, there's going to be no solutions in that given domain. And similarly for k less than or equals to -1, no applicable solutions. So the only solutions should be 0 degrees, 240 degrees, and 360 degrees. Let's double check with the left-hand solution. So again, I need my cos diagram. Where is sine positive in the first and second quadrants? So we have 30 degrees minus x. That must equal the reference angle. Sine inverse of a half is 30 degrees plus k times 360. So that's the first quadrant solution. Okay, so if I solve for x here, I'm going to have negative x equals 0 degrees times k times 360 degrees. And if I divide or multiply by -1, I could put negative k times 360 there, but because k is an integer, it could be positive or negative. So I can just leave it as k, right? Because it could be a positive or negative number. So multiplying or dividing it by a negative number will still mean it'll be either a positive or negative number, depending on the integer. So essentially the general solution is just x equals k times 360, which is exactly that solution there. And then for the second quadrant solution, it's the angle of 30 degrees minus x. 180 minus the reference of 30 is 150 degrees plus k times 360. And now I'll have negative x equals, so if I subtract 30 degrees from both sides, I'll have a 120 degrees plus k times 360. And now if I multiply both sides or divide both sides by negative 1, I'm going to have negative 120 degrees. And again, the k is an integer, so I can just write plus k times 360. All right, but now this one here, you could argue, well, that doesn't look like this solution here, but it actually is exactly the same. If I add a multiple of 360 here, then I get exactly that solution. But we can verify, right? So for this one here, we've already done all the k solutions. X equals k times 360. It gave us 0 degrees and 360 degrees. But for this one here, if I put k equals 0, no applicable solutions, right? Because you get negative 120. If I put k greater than or equals to 1, if I put 1, I'm going to get 240 degrees. If I put 2 onwards, no applicable solutions. And less than or equals to negative 1, definitely no solutions. So again, you get the 240 degree solution coming out. Okay, so those are the 3 possible solutions for this equation. Again, we can plug it in and just verify that it works for the original equation. So you have a half times cos, so we'll do the first angle was 0, minus root 3 over 2 times sine of 0. There we get a half, so that's fine. The next angle was 240. Okay, so if we go there, we get a half, great. And then the other one was 360. So we can check that as well. And we get a half. Okay, so these are definitely the 3 valid solutions in that given domain for this trigonometric equation. All right, I'll see you in the next one.